Here is the question. Figure shows the position time graph of a particle of mass 4 kg. What is the force on the particle for t less than 0, t greater than 4 second, and 0 less than t less than 4 second? And in part B, we are asked to calculate impulse at t equals to 0 and t equals to 4 second. Here we can see that for t less than 0, the position of the particle does not change with time. That is, in the region from A to O, the position of the particle remains unchanged with time. So, the particle is at rest. Therefore, force acting on the particle F equal to 0, since the particle is at rest. And for t greater than 4 seconds, here also you can see that the position of the particle does not change with time. That is, the particle is at rest for t greater than 4 seconds. So here also the force acting on the particle should be 0. And in the region 0 less than t less than 4 seconds, that is the portion of the graph OA, we can see that the slope of the line OA is 3 by 4. That is, if this angle is theta, then slope m equals to tan theta equals to 3 by 4. Now, as the slope of position time graph gives the velocity of the particle, so here we can say that the velocity of the particle is constant. Since velocity is constant, acceleration A of the particle is 0, and therefore here also the force acting on the particle F equals to ma equals to 0. So in question A, for the three cases t less than 0, t greater than 4 second, and 0 less than t less than 4 second, we have force acting on the particle 0 in the three cases. Now for the part B, where we are asked to calculate the impulse at point O and at point A. At point O, the velocity of the particle changes from 0 meter per second to 3 by 4 meter per second. Here the slope of the graph OA is 3 by 4, which gives the velocity of the particle. So at point O, the velocity of the particle changes from 0 meter per second to 3 by 4 meter per second. Hence, the impulse at O, that is IO, equals to m into V minus u, where V is the final velocity and u is the initial velocity. That is IO equals to 4 kg into 3 by 4 meter per second minus 0 meter per second, and we get 3 kg meter per second, or we can also write Newton second, the unit of impulse. At point A, the velocity of the particle changes from 3 by 4 meter per second to 0 meter per second. So impulse at point A, IA, equals to m into V minus u, where V is the final velocity and u is the initial velocity. Here we have m equals to 4 kg and V equals to 0 meter per second minus 3 by 4 meter per second. So we get minus 3 kg meter per second, which is the required impulse at point A.